I'm Jean Tournadre. I'm a collaborating scientist for OSI SAF. I'm working at Ifremer, at the Laboratoire d'Océanographie Physique et Spatiale at Brest, in the historical center of Ifremer. And I'm working mainly on iceberg and the climatology of iceberg from space data. So I have a degree in engineering from École Centrale de Lyon, and after I did the PhD not on oceanography but on ozone and tropopause folding, and after I moved to the interface between ocean and atmosphere, and then to satellite data and mainly altimetry. And that's how we discover that this kind of instrument can be used to detect icebergs. So using altimeter, we can detect icebergs, especially the smaller ones, which are between 100 meters and 3 kilometers in length. And since 1992, we have always at least one altimeter flying above the Earth. And now we got 6 of them flying at the same time. So we can construct, in fact, a climatology since 1992, so now it's 32 years old, which means that we can start to do real climatology with using this data. And this was developed at Ifremer using CNES funding. And now we are transferring this processing chain on all altimeters flying to EUMETSAT and OSI SAF, so it can go on for the years to come, at least until 2028, and maybe incorporate the future data from CRISTAL, which will be the next cryosphere studies satellite developed by ESA. So the positive of OSI SAF is that it brings scientists from different countries with the same purpose to build long-term climatological series for sea ice, icebergs now, and different parameters for the Arctic and Antarctic region, which are of prime importance for the climate studies. So my favorite satellite is JSON-1. So it's a pretty old one because it was back in 22, as long as I remember. And it's a satellite that we use to discover the method to detect icebergs. In fact, the first orbit of JSON-1, the real one, fly over the Strait of Malacca between Indonesia and Malaysia. And it flies over a triangle of beacons used for ship traffic. And those beacons are 13-meter high. And we check the data, the high-resolution data for this satellite, and we discover strange parabolas. And using the charts, nautical charts, we realize that the 3 beacons, and we could detect them, and we could measure their height using the altimeter data. And so that's why JSON-1 will be my favorite satellite. So it's not really windy today, but it's Brest, so you can check. There is the sea, gray sky, and some winds.